Solution A contains the compound CuH2O6Cl2. So what's going on here? We've got a complex ion CuH2O6 and copper is in +2 oxidation state. It's got a 2+ charge. So this CuH2O6 has got a 2+ charge and it's got 2 Cl- ions, 2 chloride ions attached to it as well. State the type of bonding between the oxygen and hydrogen in this compound. We've got waters in there, so the bonding between the oxygen and hydrogen is a covalent bond. State why the chloride ions in this compound are not considered to be ligands. Well, they're Cl- ions just attracted to the CuH2O6 2+. There's ionic bonding going on between the Cl- ions and the 2+ CuH2O6 2+. Actually, a ligand is a lone pair donor, so it forms something called a coordinate bond or a dative bond, and it's a lone pair donor. The Cl- is the chloride ions and not lone pair donors. An excess of ammonia was added to a sample of solution A to form solution B. So what actually happens is that 4 of the NH3s, 4 of the ammonias replace 4 of the waters, 2 will remain. So we've got CuH2O6 2+ and 4 ammonias replace 4 of the waters, 2 remain. It's still 2+ because NH3 and H2O have got oxidation states of 0. They've got no charges, so the 2+ still remains and 4 of the waters come off. The colour is a deep blue solution. You can also say a royal blue or a dark blue solution. Any of those will get the mark. An aqueous sodium carbonate was added to another sample of solution A, so to form a blue-green solid C. So A is copper, so it's going to make copper carbonate, sodium carbonate, and this copper complex will make copper carbonate, a blue-green solid. Reagent D was added to another sample of solution A to form a yellow-green solution. So this forms a yellow-green solution, which is actually CuCl4 2-. So to replace the waters with Cl's, you're going to have to use concentrated hydrochloric acid. And concentrated hydrochloric acid will replace those 6 waters with 4 Cl's. So 6 of the waters, 4 Cl- chloride ions make CuCl4 2-, 6 H2O. Why only 4 Cl's? It's because they're larger than the H2O ligands, and only 4 Cl's can fit around the Cu metal ion. So only 4 Cl's can fit around the Cu 2+. Now then, why is it 2+ going to 2-? Well, waters have no charge. The Cu has a 2+ charge. If the Cu has a 2+ charge here and the Cl's have a minus charge each, they're in oxidation state -1. They gain 1 electron. They're in group 7. 4 1-, 2+, leave 2- left over. Or you can look at the fact that 2+ and 4 1- is 2- on the left hand side, 2- on the right hand side. Explain why colorimetry cannot be used to determine the concentration of solutions containing CuCl2-. Well, colorimetry is used to test for coloured ions, usually transition ions. And transition ions are usually coloured because they've got incomplete 3D shells. So if you've got an incomplete 3D shell, so a 3D shell that's not full, then they'll absorb visible light. This must have a full D shell because it's not absorbing any light, it's not turning into a coloured ion. So colorimetry, which is measuring the colour of the solution, cannot be used to determine the concentration, how much colour is in this solution. This solution must be colourless, and the reason it's colourless is because it's got a full D shell that cannot absorb visible light.